I'm Anil Kumar, and here is a test question from Advanced Functions Unit 2, Rate of Change. Sketch possible acceleration time graph and distance time graph from the given velocity time graph. Now this really is the whole chapter at one place about distance, time, velocity and acceleration. Now here we are given velocity time graph. From this, we need to make an acceleration time graph and displacement, right? I ran out of space and therefore I have only one additional graph here. So what I intend to do is I will draw acceleration time graph on the same scale, right? But we'll change the vertical scale since units for acceleration are meters per second square. So let me use some different ink. So we'll say acceleration will be in meters per second square, and we'll figure out the scale soon. So what we have here is velocity and time. So what is acceleration? Acceleration A is rate of change of velocity. So basically delta V over delta T. That should help us to figure out acceleration during each interval. Now in the first interval, since the velocity is increasing at a constant rate, there is a constant acceleration, correct? Increasing at constant rate, that means constant acceleration, correct? So it increases from 0 to 10 within 5 seconds. So in the first run, it is increase is rise over run. So we'll just find slope. Basically in this, that is, we have to find slope at each interval to get the acceleration. As simple as that, correct? Now we get 10, this is meters per second, divided by 5 seconds. You get it. So you get 2 meters per second, right? So I'll use a scale where I'll use this as 1, then I'll use this as 2, 3 and 4. I think that should be good. Okay, so if I'm using that unit as 1, so I have 10 divided by 2, 10 divided by 5 as 2, so it is 2 meters square. So here we are. So between this interval we have 2 meters per second square. So that becomes the acceleration during the first 5 seconds, correct? Next, it is constant speed. That means velocity is not changing. If velocity is not changing, then acceleration is 0, right? So from 5 to 10, it is 0. So we have a horizontal line along time, right? Where the acceleration is 0. Okay. And then during this interval, we will find the slope. So let me just sketch it for you. Okay, so we are trying to find the slope. Since it's a velocity time graph, slope is going to give us acceleration in here. Meters per second square will be the unit. So rise is 40 from 10. So it is 10, 20, 30 units. And the run is from 10 to 15, 5, right? So this is 30 divided by 5, right? And 30 divided by 5, is 6. So during this time, it is 6 units, which I didn't anticipate. So 6 will be 4, 5, kind of right there on the top. So I will assume this to be 1 point and here, and I'll just draw here, okay? So that is 6, okay? Think it is 6 meters per second square. I should have anticipated that anyway, but that's, so take care, you cannot really go for that scale of 1, 2, 3, 4, 5, 6 because 6 was one of the answers. I should have taken this as half of that as 1. Anyway, but you get the idea, right? Now in this case, it is dropping down. And the change is how much? Let's calculate this change. It drops from 40 to 20. So it is minus 20, right? And the time duration is from 15 to 25, which is 10. So it is minus 2. So here it is 1 and then minus 2 is way below. So what I will do for the time being, a kind of change, break the scale, right, okay. And then from here to here, I'm just drawing a line here. And I'm saying this is the duration. Okay, we are using this color. And the acceleration is minus 2 meters per second square. Okay, I hope that works. So anyway, you get an idea that these different intervals, we have acceleration as this is 2 meters per second square, then we have 0 meters per second square, then we have 6 meters per second square minus 2 meters per second square. So that is how we can make acceleration versus time graph. Now let's make the distance versus time graph now. For distance, what we will do is we'll actually use this scale. Okay, now as the time goes by, we are talking about distance, not displacement. Distance will constantly increase. Remember that part. Second, distance will never be negative. As we saw, acceleration was negative here. Now to start with, in the first 5 seconds, the speed increases from 0 to 10. Average speed is half of it, which is 5, and 5 times 5 is 25. So we get 25 meters in the first 5 seconds, right? So 25 meters. Let's select a scale again. So we'll use this as 10 now. So I'm being safe now. So this is 10, 20, right? So 30, 40. Let's say this is 50 for us. Okay, so 25 meters in the first 5 seconds will be 10, 20, and 5. And seconds, we're talking about 25 seconds. We'll use the same scale. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That becomes 10. 1, 2, 3, 4, 5. 15. 1, 2, 3, 4, 5. 20. And 1, 2, 3, 4, 5. 25. Okay. So that is how it is going to be. 2, 3. Okay, anyway. So within the first 5, we cover distance of 25. So it is 10, 20, and in between. So that is 25 for us. So that is the distance. Right? It increases from 0 to 25. You'll also notice that the distance you can calculate by finding area under the graph. So if you find this area, you know the distance. Okay. Now here the average speed is 10 for another 5 seconds. So the distance will be 5 times 10, which is also area of this rectangle, correct? So 50. 50 more. So from 25. So this is 25. Plus 50 we are doing, so we'll go to 75, right? So this is 50, 1, 2, 3, 4, 5. This is 100, right? So 75 will be 50, 60, 70, 75 will be here. That is at 10. So at 10 we are at 75. So here, so this is the next slab, and this we are at 75 now. Correct? Now, let us find the area under this graph. That will be easier for us to work with, right? So we will find the area under this graph now, which is how much? We have a time duration of 5 into 10. This is 50, right? And then we have a height here, which is from 10 to 40 times, which is 30. Half of 30 is 15. And 15 times 5, which is the time. So we are taking half base into height. So height is 30, and then base is 5. Half of 30 times 5, right? So that is our answer. So 15 times 5. 15 times 5, 5, 5, 25 is 75. So we'll add 75 to this. So at 15, 75 plus 75 is 150. So it'll be 1, 2, 3, 4, 5. There we are. So we are here in this line, okay, and the time is 15 for us. Okay, so time is 15. So that is 150. Okay, so I'll use a different thing so that later on we can check our results. So distance further increases and that becomes the distance. This is at this point. And after that, it drops here, right? But the distance has to increase. Now, area under this graph is how much? We have to calculate that part now. So the area is, we can make this rectangle here. So we have 10 times 20. So this is 200. 10 times 20. And this triangle area is 20 to 40 is 20. Half of 20 is 10. And 10 times 10 is 100. So it's 300. So we'll add 300 to this. If you add 300 to this, you get to a value which is 450, which is kind of beyond my scale. So what I will do is, I'll take a point somewhere there, and I will say, well, this is 450 for me, okay? So this is 450, right? So 450 meters. So we have a distance here in meters, and we have time in seconds. I hope that helps you. The whole idea here is to teach you that you can always find distance from a velocity speed graph by area of, this is area of velocity time graph. That is distance, right? So distance is equals to area of velocity time graph, and acceleration is slope of velocity time graph, right? If you understand that part, then I think you can do any question relating converting this velocity time graph to acceleration time graph and distance time graph. I hope that helps. I'm Anil Kumar. You can subscribe and learn a lot. Thank you and all the best.